name of Almighty God, I'm Master Hassan Koshi, and today I want to talk about the Gauss and equations of a state, which is a subsection for thermodynamic system. Thermodynamic systems are specified by an equation of a state that constrains of the values that state variables may assume. The most famous example of this is the equation of a state for an ideal gas when PV is equal to NKBT, where P is the pressure, V is the volume, N is the number of particles, and T is the temperature. You probably know this as the ideal gas law, describing how the state variables P, V, and T are related. The only other questions of state you may see on the exam is equilibrium or equation of states for the van der Waals gas. The van der Waals gas has particles with non-zero size and a provides attractive potential. And the equation of states such as these formulations P plus n alpha to the power of t divided by v to the power of 2 multiplied by v minus nb is equal to nb t n MB and Kobe and T, where R measures the attraction between the particles and B um, measure the size of the particles. Clearly, alpha is equal to beta is equal to 0 reduces to the ideal gas constant. You should define definitely not memorizing these equations as it is will be given to you if you need it, but you should be familiar with the interpretation. Now I want to go through the another sections 4.2.3 types of processes. Thermodynamic processes can be classified into several types that have their important properties, mostly relating to holding certain variables constant. These words used to describe many of these processes are often used interchangeably, but this is sloppy. There are very precise meaning, and it is the crucial to keep definitions straight on how to which formulas applies. Here is a list of GRE most important processes you will encounter the GRE. The first one is reversible process, a process that proceeds in an infinitesimal steps, such as the steps in the equilibrium at each steps, and each influential step can be reversed by somehow changing the state of the system. A common example is slowly heating as a gas in a container or fixed size. As an infinitesimal amount of heat is added, the gas extends and comes to equilibrium after true time has elapsed. This can be reversed simply by cooling the systems or removing an equal amount from heat. Reversible process implies several important conditions. If the process involves a gas, the work done in which the infinitesimal step is given by the W is equal to P derivative based on the volume. It's a reversible equations. Note that this is not true if the process is irreversible. See free expansion below. In addition, the total entropy danger of the system and it is accordingly surrounding must be zero. The entropy of the system Bj itself can change, however, and is given by these equations. So thank you so much for watching my tutorial video until the end. Today is 29th of October of May 2026. Time is 11:44 o'clock in the morning.